Hey, it's Mr. E here, and our aim for the video is how do we determine the function for a regression model using the TI-83 calculator, and how do we extrapolate from the data. The data table below shows water temperatures at various depths in an ocean. Write the linear regression equation for this set of data, rounding all values to the nearest thousand. So they want us to write a linear regression equation for this set of data. To explain what this is, I'm just going to work out this problem and go over the definitions as I work it out. So here's what I want you to do. On your TI-83 calculator, I want you to enter the data that you see here. This is going to go on L1 and this is going to go in L2. Okay, so here's my TI-83. Go to Stat, Edit, and let's enter the data. So we got 50, 75, 100, 150, and 200. On L2, we've got 18, 15, 12, 7. Oops, I think I skipped something. 18, 15, 12, 7, and 1. I did not skip anything. So that means I have an extra number here. So let's erase that. All right, make sure everything's in there correctly. 50, 75, 100, 150, 200, 18, 15, 12, 7, and 1. And it's always good to go back and make sure you entered everything correctly. Make sure that nothing is entered incorrectly. Okay, now I'm going to make sure that my plot is on, so I'm going to press second, y equals to access the stat plots menu, and I'm going to make sure that this plot is on, because if it's not on, I won't be able to see the data. So I'm going to turn it on. I don't want it to connect the dots, so I'm going to leave it here. X list should be L1, Y list should be L2. Okay, set. Now I got to adjust the window a bit. The smallest x is 50, so why not make my x min 40? Give it a little wiggle room, so that way I can see the data really well. The largest x is 200, so I'm gonna make it 210, my x max. My smallest y is 1, make that 0. The largest y is 18, so I'll make it 20. Now, these are just, the way that I set up the window is I want to give it a little wiggle room. So if the smallest x is 50, then I'll make my x min 40. Give it some room in the graph. This way, everything isn't so bunched up. Okay, after I adjusted my window, I'll hit graph. And if you have the same window settings as me, you should see a graph that looks like this. All right, write the linear regression equation. So what is a linear regression equation? A linear regression equation is the line that best fits this data. So that's why it's also called the line of best fit. So think about it. If I was to just draw a line that would best fit this data, how would I draw it? Well, I would draw it something like that. And maybe I would do it like that. There you go. I think that's the line that best fits the data. But that's just my human opinion. The calculator can really give you a better approximation of the line of best fit. So let's get the calculator to do it for us, and that would be the linear regression equation. So to do that, you're going to press stat, you're going to go to calc, and you're going to go down to linear regression, and then parentheses it says ax plus b, or you can just press 4 and press enter. So as you can see, the linear regression equation is in the form of y equals ax plus b. A represents the slope, b represents the y-intercept. In this case, our a, see if I can move this a little bit. Our a represents negative 0.112, rounded to the nearest thousand. I'm rounding to the nearest thousand because that's what it says. And our b is 23.448 rounded to the nearest thousand. So that means our linear regression equation is y equals negative 0.112x plus 23.448. That's our linear regression equation, or our line of best fit. Let's go ahead and graph that line on our calculator to see what it looks like and how it fits the data. So we got negative 0.112x plus 23.448, and press graph. So it's a very it fits the data very well, as you can see. Now, why do we have linear regression equations? We can use linear regression equations to extrapolate from the data. Now, what does it mean to extrapolate? You saw that word in the aim. To extrapolate means to predict. So if we look at this next task here, it says, using this equation, predict the temperature in Celsius to the nearest integer at a water depth of 255 meters. See, that's not part of our data. Our data goes up to 200. They want to know, what's y going to equal when x is 255? Well, now that we have a model here, we can use that model to make that prediction. So what does y equal when x is 255? Well, all we have to do is just plug into our equation, and we are going to get it. And we get y equals negative 5. So that's our answer to this question. It says to round to the nearest integer, so that's why I rounded it to negative 5. Okay. When doing lines of best fit, it's important to know that you can have either a negative correlation or a positive correlation. So positive correlation looks like this because the line of best fit would be a positive line, and negative correlation looks like this. The line of best fit would be a negative line. Now here's the thing with correlation. -1, so that means the slope of the line. When the slope of the line is -1, that's a strong negative correlation. When the slope of the line is +1, that's a strong positive correlation. The closer the slope is to 0, the weaker the correlation is. Okay, so let's move on to another example. The accompanying table shows wind speed and the corresponding wind chill factor when the air temperature is 10 degrees Fahrenheit. Write the logarithmic regression equation for this set of data, rounding the coefficients to the nearest 10,000. So as you could see, we're not being asked to do a linear regression here. Now it's a logarithmic regression. Now you should know that there are 4 types of regressions you can perform, and they are listed here for you. And this is from regentsprep.org. We have the linear regression, which is what we just performed in our first example, the logarithmic regression, which we will perform now, and then we have exponential and power regression. You're supposed to be able to look at the data and decide which of these models will best fit the data. You're supposed to be able to do that. Now, if you're not, you're kind of in luck, because I haven't seen a problem on the regions yet that makes you decide which one best fits the data. Usually what I've seen is they'll tell you what to use. So in this case, they're telling you to use logarithmic regression for this data here. But in my class, you're supposed to be able to look at the data and tell which one best fits. So let's go ahead and get this logarithmic regression by inputting the data in the calculator first. So go to Stat, turn on calculator, stat, edit, and let's enter our data. So we got 4, 5, 12, 16, 22, 31. And then we got 3, 1, -5, -7, -10, and -12. And then always make sure that you entered everything correctly. So 3, 1, -5, -7, -10, -12, 4, 5, 12, 16, 22, 31. All right, great. So make sure the plot is on for L1 and L2. It already is. And we're going to have to adjust our windows a bit. So the smallest x is 4. I'll make it 0. You know, give it some wiggle room. The largest x is 31. I'll make it 35. Give it some wiggle room. Well, why not? It was 38. Make it 38. I mean, like I was saying earlier, these are just arbitrary numbers. Just make sure you have enough wiggle room in the graph so that everything isn't bunched up. Our y min should, so our smallest y value is -12. So I'll make this, why not, -15. And our largest y value is 3, so I'll make it 5. Press graph. And there's our graph. So as you can see here, you could tell by looking at it that a linear regression is not the best. It would not give you the best model for this. By looking at it, you can tell that this is not going to be linear. It's going to be a logarithmic, and they even tell you to use a logarithmic. Okay, so to get the logarithmic regression, just press stat, go to calc, go down to LN regression. That LN means natural log. So, or just press 9. So natural log regression, or just press 9 and then press enter. So this logarithmic regression is in the form of y equals a plus b natural log x. And they want us to round to the nearest 10,000th, as you can see there. So these will be our values for A and for B. When you substitute for A and for B, this is the equation you get. Okay, here's what I want you to try now, and write your answer in the comment section. Using this equation, find the wind chill factor to the nearest degree when the wind speed is 50 miles per hour. Okay, I hope this video helps. Take care.